Good afternoon, students. Welcome once again in YCS Sultanpur. Today we are going to discuss mensuration. The mensuration chapter is related in standard 7. The mensuration, rectilinear figure. So first of all, we learn about the rectilinear figure. Rectilinear figure. What is rectilinear figure? A figure made of different line segments in open chain. Suppose line segment this, this, is known as rectilinear figure. There is no end. So the figure made of line segments without any ends. And we would like to learn about the closed figure. What is closed figure? Closed figure a figure made of line segments with no end. The figure no free end. That means the made of line segments, these are with no end. For example, square, rectangle, trapezium, parallelogram, triangle, etc. So, dear students, we are going to learn about the closed figure, area and perimeter. So, first of all, we should learn about the perimeter. What is the perimeter? The perimeter of a plane figure is the length of boundary. The perimeter is a plane figure, perimeter of a plane figure is the length of the boundary. That means, suppose we have this figure and we should name it A, B, C and D. So, the perimeter is the length of this closed figure boundary. Length of this closed figure boundary, that means AB plus BC plus CA plus AD. This is the perimeter of this particular figure. Similarly, in the case of rectangle, trapezium, parallelogram, so the length of total boundary is known as perimeter. So today we are going to learn about the perimeter of different closed figure. First of all, we will learn the perimeter of rectangle. Suppose we have a rectangle and rectangle A, B, C, D. What is the property of this rectangle? This is already discussed in previous videos, that the opposite sides are parallel and equal and diagonals are equal. In the case of rectangle, the opposite sides AD is equal to BC and AD parallel to BC. So, the BC is the length, so BC equal to AD2 and AB equal to CD. So, we have the perimeter of ABCD ABCD equal to AB plus BC plus CD plus DA. Here we will put the values AB, B plus BC L plus CDB and plus DAL. So we have now L plus L, we will write in sequence B plus B. Again we have 2L plus 2B and we will take 2 common, 2L plus B. This is the formula of perimeter of rectangle. Similarly, we will find out the area of rectangle. Area of rectangle. Suppose we have one rectangle A, B, C, D. So we know that the diagonals divide rectangle into two congruent triangle. Diagonals divide any diagonal. Suppose this ABCD is our rectangle and AC is dividing into two congruent triangles. First one is ABC and second one is triangle ADC. The area of both the triangle is equal. Area of both the triangle, area of ABC equal to area of ADC. This has been already discussed. So, we will find the area of triangle ABC. That we already know. The area of triangle ABC equal to 1 by 2 into base into height, base into height. So what is the base? Base is BC. Base is BC. So 1 by 2 into BC and height is AB. Suppose BC is L and AB is B. Then here 1 by 2 L into B. And we know that here from this you write this equation number 1. From equation number 1 you will see the area of ABC equal to area of ADC. So the area of ABC and ADC total combinedly make this total rectangle ABC plus triangle ADC make together rectangle ABCD. Here we have the area of ABC equal to area of ADC. Then we will write here area of ABC plus area of ADC equal to area of ABCD. Here you can write here area of ADC. Now put the value 1 by 2 into L into B plus 1 by 2 into L into B. That is the equal to area of ABCD. So we have here 2, so 1 by 2 plus 1 by 2, 2 by 2 into L into B equal to area of A, B, C, D. 2 cancel by 2, we get here L into B equal to area of ABCD. So dear students, finally we find the area of rectangle ABCD equal to L into B. Clear? Now, similarly, we will find the perimeter of square and area of square. Perimeter of square, that according to the definition, the total length of boundary. Suppose we have square ABCD, A, B, C, D. So the length of boundary means AB plus BC plus CD plus DA. Suppose in previous videos we had discussed about the square. The opposite sides of square are parallel and all sides are equal. Suppose AB is A, so BC is also equal to A, CD is also equal to A, and DA is also equal to A. All four sides are equal and opposite sides are parallel. At the same time, we had discussed the diagonals are equal and bisect each other at 90 degree. So we have here AB A plus BC A plus CD A plus DA A. That means A plus A 4A. You can write this 4 into side. So this is the perimeter of square. Now we should find this. This square, diagonal of this square is also dividing into two congruent triangle. Therefore the area of ABC equal to area of ADC. So area of ABC equal to area of ABC. Here we can write, we know that ABC plus area of ADC equal to area of square ABCD. So area of ABC 1 by 2 into A into A. Here area of ADC, so this triangle we take 1 by 2 A into A. That is equal to area of ABCD. Write down this area of ABCD equal to 2 by 2 A into A. 2 cancel. Here we get A into A. You can write this side into side. So here the area of square, side into side. Now we will learn about the area of parallelogram. Area of parallelogram. Suppose we have one parallelogram A, B, C, D and join this AC diagonal So before going to find the area of parallelogram, we should know the property of parallelogram that we had already discussed. That is, the diagonal of parallelogram divide into two congruent triangle. That means ABC equal to ADC and opposite sides are parallel. Diagonals bisect each other but not in 90 degree. They bisect each other but not at 90 degree. So we have these two triangle 1 and 2. Suppose this is the height AD. So we have triangle ABC. First area of triangle ABC we will find, that is equal to 1 by 2 into base into height. See here, 1 by 2, base is BC into height is AD. And we know that the area of parallelogram ABCD equal to 2 into area of ABC. Now we will put the value of area of ABC, 2 into 1 by 2 into BC into AD. 2 and 2 cancel, 2 cancel, we will get here BC into AD. So finally the area of parallelogram is base into height, base into height. Clear? Area of parallelogram, base into height. Now we will learn about the area of rhombus. So before going to find the area of rhombus, we will know the property of rhombus first. Area of rhombus. Suppose we have rhombus ABCD, ABCD. In the case of rhombus, all four sides are equal and opposite sides are parallel. All four sides are equal and opposite sides are parallel. And diagonals bisect at 90 degree. AC and BD bisect at 90 degree. Suppose this point is, bisection point is O. So we have here four triangles, OBC, OBA, OAD and OCD. We have here four triangles. We will find out first the area of OBC. Area of OBC, that is equal to, in this case, see, you can take this height or either this height, because this angle is 90 degree. This one is 90 degree already, according to the property of rhombus. Diagonals bisect each other at 90 degree. So this one is 90 degree. So this OBC is right angle triangle and at angle at O. So we take this OB as a base and OC as a height. So 1 by 2 into OB into OC. So and this OBC is equal to OBA. This has been already proved. OBC, the area of OBC equal to area of OBA equal to area of OAD equal to area of OCD. We can write here area of OBC equal to area of OBA equal to area of OAD equal to area of OCD. So we have the area of OBC 1 by 2 into OB into OC. This from equation 1 we will find this rhombus area of rhombus equal to, there are 4 triangles, so 4 into OBC, area of OBC. Area of OBC. Now this put the value 4 into 1 by 2 into OB into OC. Two into OB into OC. 2 into OB into OC. 2 OB, that means we can write this 1 by 2, take 1 2 more, take 1 2 more, 2 into 2. That means 2 is already there. We take another 2, we multiply into numerator and denominator. 2 into 2 into OB into OC. See here 1 by 2 into 2 OB into 2 OC. We take separately. These 2 we had taken with OB and these 2 we had taken with OC. 2 OB. In this figure you can see what is 2 OB. This is bisecting. This bisection point is O. So OB equal to OD. That means 2 OB equal to BD. 2 OB equal to BD and 2 OC. 2 OC equal to AC. So we will write here 1 by 2, 2 OB equal to BD and 2 AOC equal to AC. Now see in the figure, in this figure, what is BD? BD is diagonal, diagonal 1 and AC is diagonal 2. So we will write here 1 by 2 1 by 2 into D1 यानी diagonal 1 into diagonal 2 AC. Just review this once again. Area of rhombus. We have the rhombus ABCD, and diagonals are BD and AC. And according to the property of rhombus, we know that diagonals bisect each other at 90 degree and all sides are equal. So we are not taking the all sides are equal, we are taking only the diagonals bisect each other at 90 degree. So we have 4 triangles OBC, OBA, OAD एंड ODC. हमारे पास 4 ट्राइंगल हैं और चारों के एरिया इक्वल हैं. दैट इज ऑलरेडी प्रूव्ड. ये पहले से प्रूव किया जा चुका है. तो ओबीसी का ट्रायंगल का एरिया निकाल करके हम 4 से मल्टीप्लाई कर देंगे तो हमको पूरे इस रोहम्बस का एरिया मिल जाएगा. सो तो फर्स्ट वी फाइंड द एरिया ऑफ ट्रायंगल ओबीसी. तो इन द केस ऑफ ट्रायंगल ओबीसी, द बेस इज ओबी and height is OC. We have taken, and this is right angle triangle because diagonals is already bisecting at perpendicular, that means 90 degree. So this is right angle triangle. So 1 by 2 into OB into OC. Then again we will multiply by 4 into area of OBC, that is equal to OBC, the area of OBC equal to 1 by 2 OB into OC. Again we have this, after calculating this 2 by 4, 2 into OB into OC. Now we will take 2 and multiply both sides up and down, means numerator and denominator. So we get 1 by 2, 2 into 2 OB OC. We take these 2 ये दोनों दो जो है हम एक 2 हम OB के साथ लेंगे, एक 2 हम OC के साथ लेंगे. तो 2 OB इक्वल टू BD and 2 OC equal to AC. That means BD into AC. And here BD is diagonal 1 and AC is diagonal 2. So this is all about the area of rhombus. Once again just review the what is rectilinear figure. The figure made of same line segments without no free end, with free end. And the closed figure, the figure made of line segment with no free end, that is closed figure. For example, rectangle, triangle, trapezium, etc. So we have already learned about the perimeter of rectangle, that is the length of boundary, means rectangle has 4 sides. So the sum of all 4 sides, that is equal to the perimeter of the rectangle. That comes 2, because it has 2 length and 2 breadth, so 2 under bracket L plus B. This is the perimeter of rectangle. Now if we take the area of rectangle, so according to the property of rectangle, the diagonal of rectangle divides into 2 congruent triangle. That means the area of 2 triangles are equal. So we will find the area of one triangle, that ABC, that we got 1 by 2 base into height, and multiply this by 2, or just you add this 2. So we get the area of rectangle equal to L into B, length into breadth. Similarly, in the case of perimeter of square, all 4 sides are equal. Therefore, to 4 into side, that is the perimeter. And the area, similarly, as we had find in rectangle, we can find out the area of square, that diagonal is dividing into 2 congruent triangle. We will find the area of one triangle and double it. So here we have A into A, means area equal to area of square equal to side into side. And similarly, in the case of parallelogram, the area of parallelogram we have already found, that base into height. We had taken that diagonal dividing into 2 congruent triangle. The area are the same of both the triangle. That's why we find one area of one triangle and double this, we will find the area of parallelogram. Similarly, in the case of rhombus, we have find that 1 by 2 into diagonal 1 into diagonal 2. One more point is left here, the unit, standard unit of area. So whatever the unit is there, that is multiplying by itself. That means if meter is there, so meter is there, to meter into meter, square meter. Centimeter is there, cm into cm, square centimeter. Decimeter is there, if decimeter into decimeter, square decimeter. Millimeter is there, if millimeter into millimeter, square millimeter. This is the standard unit of area, square millimeter. So this is all about the rhombus. Some other figures are there, we will discuss in next videos. Thank you very much.